Hello, this video is for Algebra 1 textbook, Chapter 2, Lesson 2. It is titled Solving Equations by Multiplying or Dividing, where our objective is to solve one-step equations in one variable by using multiplication or division. Who uses this? Well, pilots can make quick calculations by solving one-step equations. We'll see that in example 4. Solving an equation that contains multiplication or division is similar to solving an equation that contains addition or subtraction. Use inverse operations to undo the operations on the variable. Remember that an equation is like a balanced scale. To keep the balance, whatever you do to one side of the equation, you must also do to the other side. And we've talked about that in a previous lesson, where what you do to one side, you have to do to the other. Those are the properties of equality. Last lesson we talked about the addition property of equality and the subtraction property of equality. And this time we're going to talk about the multiplication and the division properties of equality. And this is because multiplying and dividing are inverse operations to one another. If x is being multiplied by some number, you can undo that operation by dividing by that number. And if x is being divided by a number, then you can undo that division by using multiplication. And we'll look at some examples of that. So in our first example here, example 1, solving equations by using multiplication. Solve each equation, check your answer. Well, here we have in example A, -4 equals k divided by 5. So since k is divided by 5, then multiplying both sides by 5 will undo the multiplication. So on the left, we're going to multiply -4 by -5, and we're going to multiply k divided by -5 by -5 as well. And what's going to happen is these 5's are going to cancel each other, leaving us with just k. Negative times negative is positive, and 5 times 4 is indeed 20. Now some people wonder, what do you mean that, how is it that whenever you multiply by the denominator, if you multiply the k divided by 5, -5, and if you multiply it by 5, how does it just become k? And to some people that's kind of confusing. So if I have k and I divide it by -5, if I want to just get k by itself, I can also multiply times -5, which is what you see them doing here. But instead of just writing it -5 is -5, I'm going to write it as a fraction. So that I have -5 over 1. Remember, we can take any value, put it over 1, and it still has the same value. Now, if I put this back together, if I go ahead and do a fraction multiplication, just multiply straight across, I would get k times -5. And at the bottom, I would get -5 times 1. Now, if I go ahead and switch the place, use the commutative property of multiplication, if I switch the -5 and the k and change their positions, and down here I'll leave the -5 and the 1 in the same order. Now, I can pull these apart. I'm going to go ahead and do that down here. Now I'm going to take -5 times k and write it as -5 times k, and these are going to be fractions still. And here I have the -5 times 1. Well, -5 divided by -5 is going to equal 1, right? Any number over itself is equal to 1, so I would end up with a value of 1 times, now let's bring the k over 1, k over 1, and another rule that I know is that any number over 1 is equal to itself. So then I would have 1 times k, and anything times 1 is equal to itself, so I end up with just k. So it's a long way around. A lot of stuff's going on from here to here. So whenever that we go from here, actually it's a pretty big circle there. Whenever we go from this to this, what's going on is all of this over here. You've got some commutative property going on. You got that concept of anything over 1 is equal to itself. Or I'm saying anything over itself is equal to 1. Yes, anything over 1 is equal to itself. You got a whole bunch of stuff that's going on over there. And so this is why that whenever you multiply times a denominator, that the fraction just kind of goes away and you end up with whatever's in the numerator. So that's the whole process there. I figured I'd go ahead and share that with you. That gets kind of confusing for some people. So that's the little, you might call it magic that's happening whenever you multiply by a denominator. You can always check your answer by plugging it back in. We said that k was equal to 20. So we'll put 20 in the place of k. 20 divided by -5 is indeed -4, so that checks out to be the correct answer. On example B, here we have m over 3 equals 1.5, or m divided by 3. We're dividing by 3. The m is tied to the 3 through division, so the opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 3, and what we do to one side, we're going to have to do to the other. The 3's are going to cancel each other, leaving us with just m, kind of like we did over here with the k earlier. And 3 times 1.5 is 4.5. We can always check our answer, plug the 4.5 back in, divide 4.5 by 3, and indeed we do get 1.5. Let's do an example down here. I don't know, 1b looks pretty good. So let's do -13 equals y over 3. I see that the y is tied to the 3 through division. The opposite operation is multiplication, so I'm going to go ahead and multiply by the number I wish to get rid of, which is 3. And what I do to one side, I have to do to the other. The 3's are going to cancel each other, leaving me with just y on the right. And then a positive times a negative is going to equal negative. And 3 times 13 is 39. So on this one here, y would equal 39. -39. Yep, be careful there. So -39 divided by 3 indeed equals -13. Guess we could do one more. P over 5 equals 10. P over 5 equals 10. I'll go ahead and choose this because the variable is now on the left. The P is tied to the 5 through division. Multiplication is the opposite operation. Here, let's start over. The P is tied to the 5 through multiplication. The opposite operation. Nope, I got it wrong again. The P is tied to the 5 through division. The opposite operation is multiplication. I'm going to multiply by the very number I wish to get rid of, which is 5. And what I do to one side, I'm going to do to the other. You probably realize I have said that a lot. The 5 is going to cancel each other, leave me with just P on the left. And 10 times 5 is indeed 50. 50 divided by 5 equals 10. Indeed, it does. Example 2, solving equations using division. So here we have 7x equals 56. Now you could probably solve this without doing that. You could think 7 times what number equals 56? And you're like, oh, okay, that's 8. But it's not always going to be that easy. You just can't mental math in your head. Sometimes you're going to have to, you'll have larger numbers, decimal numbers, those type of things. So you'll actually want to be able to be good at using this process. So we're going to rewrite that. 7x equals 56. So the 7 is tied to the x through multiplication. The opposite operation is division. And remember, every fraction is a division problem. So we're going to use division to undo the multiplication. We're going to divide by the very number we wish to get rid of, which is 7. And what we do to one side, we're going to do to the other side. The 7's will cancel each other, leaving us with just x. And 56 divided by 7 is indeed 8. We can plug that back in. 7 times 8 is indeed 56, so it checks out. On item B, or example B, we have 13 equals -2w. The -2 is tied to the w through multiplication. The opposite operation is division. Every fraction is a division problem. We're going to divide by the very number we wish to get rid of, which is -2. And what we do to one side, we are going to do to the other side. The -2's cancel each other, leaving us with just w. And 13 divided by -2 is a -6.5. And you can see if we plug that back in, indeed we get 13 equals 13. And it all checks out. Let's do number 2a. 16 equals 4c. Now the answer is 4, because 4 times 4 is 16. But the 4 is tied to the c through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, and what we do to one side we do to the other. The 4's will cancel each other, leaving us with just c on the right, and 16 divided by 4 is 4. Therefore, c equals 4. Over here with 15k equals 75. 15k equals 75. The 15 is tied to the k through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, and what we do to one side we are going to do to the other. The 15's will cancel each other, leaving us with k, and 75 divided by 15, I believe, is 5. Yes, indeed it is. So therefore, k equals 5. So how do we undo division? We use multiplication. How do we undo multiplication? We use division, because they are inverse operations, correct? So let's look here. Remember that dividing is the same as multiplying by the reciprocal. When solving equations, you will sometimes find it easier to multiply by a reciprocal instead of dividing. This is often true when an equation contains fractions, and that is indeed a good way to get rid of a fraction, is by multiplying times its reciprocal. So here we have 5 over 9 times v equals 35. Well, we want to get rid of the 5 ninths times v. And so the way that we're going to do that is we're going to multiply times 9 fifths. And here's the reason that that works. Then the reciprocal is whenever you just flip the numerator becomes the denominator, and the denominator becomes the numerator. So it's just flipping the fraction over, right? So the reason that that works is, let's take this 9 over 5, and then we're multiplying it times 5 over 9. And what happens is you get 9 times 5 is 45, and 5 times 9 is 45, and anything over itself is equal to 1. And so you would end up with 1. This here would have a value of 1, and then 1 times v is just v. So that's the reason that multiplying by a reciprocal, multiplying a fraction by its reciprocal, just kind of makes it go away. Now there would be a long way around this that you could do. You could say 5 over 9 v equals 35. You could then multiply both sides by its by the denominator. You multiply by 9, and the v, you would have to realize that the v can go up in here, so you could actually write this as 5v over 9 equals 35, and then you could multiply by 9, multiply both sides by 9, the 9's would cancel each other, you'd end up with 5v equals, and 35 times 9 would be, what is that, 270 plus 45, I think I'm going to use a calculator for that one. 35 times 9 is 315. 315, and then you could divide by 5, and the 5's would cancel each other, leaving you with v, and 315 divided by 5 equals 63. So there's another way to get there. You could actually do it without multiplying times the reciprocal. However, multiplying by the reciprocal is probably going to be the easiest way to do that. And looking at the left, whenever we multiply 9 fifths times 35, so 9 fifths times 35, I'm going to write it as a fraction. Back, don't need a 5 there. And 5 divided by 5 is 1, and 35 divided by 5 is by 5, 6, 7. There we go. And 6 times 7, 9 times 7 is 63 over 1, and that equals 63. So there's the math for what was going on over on that side there. All right. Looking at the next problem here for B, we have 5 halves equals 4y over 3. So good. I'm looking at this problem here. I'm like, bet they're showing how, in this case, notice how the y just kind of pops out of the numerator and then rests over to the side of it. And the reason for that is you could have 4 over 3 times y, and we could write that as 4 over 3 times y over 1, and then that would be 4y y over 3, right? Which is what we have right here, 4y, or 4 over 3 times y, 4/3 times y. And so this is a good illustration of understanding that if you have a variable with the numerator, it can just kind of either pop out of, you can just kind of like pull it out and put it over here to the side, or like I was saying earlier, if it were out to the side, whenever we had the 5 over 9v, that you could have pushed that up into the numerator and had 5v over 9. But either way it works. You can just kind of move that variable in and out of the numerator. Now you can't do it with the denominator. You can't just pull it in and out of the denominator like that, but you can pull it in and out of the numerator. So they go ahead and in this one here, we're going to pull that y out and rewrite it with the y over here as a separate factor from the 4/3. Now we want to get rid of the 4/3, so we're going to multiply by 3/4, the reciprocal. That means that 3 times 4 is 12, 4 times 3 is 12, 12 over 12 is equal to 1, 1 times y equals y. That's everything that's going on from there to there. And here we have, is anything canceling? No. 3 times 5 is 15, 4 times 2 is 8, we end up with 15 over 8 equals y. We'll do 3c down here. 1 over 6w equals 102. So we want to multiply by the reciprocal. 6 over 1 times 1 over 6 w equals 102. And I'm going to write this 102 as a fraction, and I'm multiplying it by 6 over 1. So I'm actually multiplying it by 6, right? So let's go ahead and get rid of the fraction, then that would work. So we're just doing 102 times 6. This would end up being 6 over 6, which would end up being 1. 1 times w is just w, so those cancel each other out, right? We just end up with a w. And 102 times 6 is 612. So in this case, w equals 612. All right, aviation. How might a one-step equation involving multiplication or division help an airline pilot fly an airplane? Aviation application. The distance in miles from the airport that a plane should begin descending divided by 3 equals the plane's height above the ground in thousands of feet. If a plane is 10,000 feet above the ground, write and solve an equation to find the distance at which the pilot should begin descending. So the distance divided by 3 equals the height in thousands of feet. So distance d divided by 3, remember every fraction is a division problem, equals equal sign height in thousands of feet. So now we need to substitute 10, since it's 10,000 feet. We don't need to put a whole 10,000 here because this is in thousands of feet. So how many thousands of feet are there? There are 10 of them. So we're going to put a 10 there. So let's go ahead and multiply both sides by 3, right? The d is related to the 3 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is the 3. The 3's, and what we do to one side, we do to the other. And the 3's will cancel each other, leaving us with d. 3 times 10 is 30. Therefore, the pilot should begin descending 30 miles from the airport. Over here the caution is what I was pointing out there. The equation uses the plane's height above the ground in thousands of feet, so substitute 10 for h, not 10,000. So I guess I should have looked over there, then I could have read that, included that into the presentation at that point. So now you have used 4 properties of equality to solve equations. These properties are summarized in the box below. So we have the addition property of equality. It basically says if you add something to one side and also add it to the other side, then the equation remains equal. Subtraction property of equality. If you subtract something from one side, as long as you subtract the same amount from the other side, then you still have an equal statement. Multiplication property of equality says that if you multiply one side by a number and you also multiply the other side by the same number, then you maintain equality in that statement as well. And then likewise, division property. If you divide something on the left and also divide it by the same value on the right, then you will end up with a true statement still. You'll maintain the equality of that statement. So here's our guided practice. We'll pick out, let's first do one using multiplication to solve it. So we have k over 4 equals 8. So k is tied to the 4 through division. The opposite operation is multiplication. So we're going to multiply by the number we want to get rid of, and what we do to one side, we do to the other. The 4's will cancel each other, and we end up with k on the left, and 8 times 4 is 32. Looking for one using division. Let's do the 4x equals 28. 4 is tied to the x through multiplication. The opposite operation is division. Every fraction is a division problem. We're going to divide by the very number we wish to get rid of, which is 4. And what we do to one side, we're going to do to the other. The 4's cancel each other, leaving us with x, and 28 divided by 4 is 7. So therefore, x equals 7. And let's do one where we have to use a reciprocal. We'll go ahead and do number 17 here. So we have 1 over 10 equals 4/5 times y. So the 4/5 is tied to y through multiplication, but we don't want to really use division. This is a fraction, so we're going to go ahead and we're going to use the reciprocal. We're going to take 4/5, flip it over to 5/4. We're going to multiply it times that 4/5. The 5/4 is the reciprocal of 4/5. Just flip the fraction over. We still have that variable y out here. And what we do to one side, we're going to do to the other. So we're multiplying 4/5 by 5/4. So we're going to put 5/4 here. We're going to multiply that times 1 over 10 on the left. So these are going to cancel each other out. It's just going to leave us with y over on the right. And then I can simplify this. 5 divided by 5 is 1. 10 divided by 5 is 2. So 1 times 1 is 1. 4 times 2 is 8. Therefore, y equals 1 over 8. All right. So that completes my presentation for Algebra 1, Chapter 2, Lesson 2, Solving Equations by Multiplying and Dividing.